Thank you, George, for the presentation. And thanks all the people who are joining us as well, presenters and the participants. And it's a pleasure for me to be join this webinar, and I'm going to explain products that we have developed and produced on this project. My presentation is going to be as a general concept at the beginning from the manufacturing technique, as Eduardo said. ATERSA and Acciona are the two partners who are taking care about the production of the modules with this new technique, and I'm going to share with all of you the manufacturing technique, but just a general view because it's quite complicated, just to have an idea about how it's works. We'll explain something about the technique. Among that, I will explain the design premise. I mean, before to do or to reach the final design of all the BIPV components, it has to be a really discussion about the spaces, electronics, what kind of cells we are going to use, the space that we can do, and so on. And finally, I will show you its BIPV design in more detail. Okay, as a general view, I mean, this new manufacturing technique is completely different than the standard one that Eduardo already explained. And we are not using glass, we are not using ABA. In this case, we are going to use fiberglass, epoxy resins, and the cells, of course. Then what we do is to manufacture a mold with the proper shape that the final element will have, and using a mold. After that, you can see here, let me take the arrow point if it works. Okay, this is the general view with the mold on the back, the vacuum pump, and this is the D element. Then we, in our case, we put fiberglass on the front. Then we place all the cells and interconnect in order to put inside all of them. Then we place the back fiberglass, and of course all the elements needed to do the infusion. That means infusion channels, vacuum cams, release sheet, and so on. And when the vacuum is properly done, then we start to fill in the system with the appropriate resin. At the end, this is the final aspect of the sample. Of course, this one, it's amount that painted in black. The final, after this process, you will get a semi-transparent module, but this is the final aspect after being painted. Why this technique? I mean, Tenalia showed this technique to ATERSA and of course to Acciona, and we were interested for these main reasons. We can manufacture a shaping module with glass. It's impossible or nearly impossible. The modules can be integrated easily as a BIPV, more easy than standard ones. The modules are lighter than the standard one, much more than glass too, because even the glass is flat and always is more heavy. And the modules can be painted on the cell area. The standard one with the glass, it could be, but it was more difficult to do it. Then we are going to start with the design premise in order to reach the final product. I mean, I'm going to focus in the roofing single product that I think is the most well designed. The first what we have to do is identify the total area to be covered by the BIPV elements. In this case, you can see we have two different roofs, and what was designed is which is the minimum element that we can reply and cover all of these two roofs. Okay. Then it has to be some premises. All the BIP should have the same dimensions to cut down costs. I mean, if you have designed different size or different shapes, you can do it, but you can design different modules, different infusion strategies. Then what is more common, it has to be the same shape and dimension for all the pieces. Okay? And of course, the final designs have to be as much as possible integrated on the building. There are several guidelines for architects edicted on this project, as Akir said before. Okay? In most of the case, the modules should be compatible with the standard solar cells. I mean, you always have to be in mind that the cells are not flexible, the standard ones, and the size of these cells. Right now, the most common cells are 156 high and wide, but to be honest with you, nowadays we are moving to a little bit high. It's only 0.75 millimeters. In one cell, it's nothing, but if you make modules with two cells or more than that, the final dimension are considerably different. This is the example from the roof shingle, and this is the beginning of the construction. It was the design on the drawings and the final aspect. Okay, move to. This is what I told you about. The standard cells are not flexible. Then also the design itself, it could be just flat. You have to design flat zones on the modules to place the cells. Okay. In this case, all the cells were placed here, 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 and here. This is one view, and this is 90-degree views. So all the cells are in this. Okay. Regarding the electrical connection, as you know, modules and all the cells have to be connected. The most reachable way it's in all the cells have to be in serial, and of course you have to use diodes in order to protect the shadow. Why? Because most in BIPV it's really common to have shadows, and you need to protect the cells. Okay. Then we have to design the cells interconnection in a way to facilitate the electrical connection to each module. Also, it is possible to use 1, 2, or several junction boxes per module. In order to cut down the cost and simplify the interconnection system, it's highly recommended to use only one junction box. Why? Because built in this junction box you will have the diodes, and otherwise you have to install external junction box or external system when you have to place only a junction box to have the diodes, and all of this is complicated. Okay. The cables and connector is designed to be as high as possible. At the beginning, one of the design, the skylight, it was designed to install the junction box in the middle of the module. You will see later. But it was not a properly way, because if you install in this part, there are not cells, and from the other part you will see the junction box. There is no aesthetic. It's aesthetical, really awful. Then all of these things have to be thinking from the beginning of the design. Okay. Here I have some samples on 2 diodes junction box, 1 zero diodes. We use this in some of the design, but then we need to add in an external way junction box like this with 1 diode in order to protect all the cells. Then the best way is to use only 1 junction box and place in a right place. Other premise is of course the inverter. Which inverter we are going to use at the end? Of course the inverter has to be designed having in mind the modules, the voltage, and all of this stuff. Otherwise, for example, you can choose one inverter, and when you finish your installations, you realize that the power is too much or too low, or even the voltage doesn't fit the PMPV position correctly, then inverters will be the key to identify how many modules could be connected in serial and vice versa. All the system has to be designed as a whole before they design the module design. Other tips are, for example, to serial the modules in a way that the total length of the DC cables to the inverter were as short as possible. I mean, you can serial the modules as you want, but you have always have in mind that as less cables that you use, it will be better for the performance rate. Well, another design, another premise design is the interconnection uses. I mean, at the end, all the modules have to be connected in serial, or most. It's the normal way. I mean, in this is was slightly special, but the diodes and all the systems that you install have to be designed thinking about the sample. This case, for example, is the Greek demo sheet. Here you can see the ventilator facade design, 1, 2, 4, 6, and 7. On the beginning it was 9, but we designed to compare with the standard ones. Here are 3 standard modules, because this will give us the opportunity to compare the new technology with the standard one technology. But as you can see here, the other BFIRST design, the roof, the shadowing element is doing shadow not only to the window of the another modules. Then this is a problem. This you have to be in mind always before to do any design. In this case, this is not a really big problem, because all of these modules have a microinverter. That means this shadow will not influence in the performance ratio of the top one. This is not affected to this module, and so on. But it will be desirable that these things doesn't happen. And other issue that we have to be in mind, and most of the BIPV systems modules are placed in a not optimized orientation. What that means? That means that the maximum power will always be less than this right on the module level. One module with 100 watts peaks normally never give this power due to the temperature, but in this case, due to the not properly orientation, you are going to obtain less power. Then this you have to be in mind to design to elect the inverter and so on. For example, one installation in Athens with 1.5 kilowatts peak of solar modules installed in an optimized orientation, you will give 2,432 kilowatts per year, but when you put in a 90 degrees orientation, you only get 1,524 kilowatts peak per year. That means only a 63%. All of this stuff have to be in mind when you design the system. All of this before to start to do nothing. Okay, right now I'm going to show you the final designs that wins, because at the beginning we have many different designs that we have to decide which one we'll choose. Then at the end we choose 5, and I'm going to show you the 5 winners designs. As you see before, this is the ventilator facade. As some of my colleagues explained, it was located in Pikermis, Athens, close to Athens in Greece. The configuration are the 60,000 area. It's quite common configuration in the standard field, 22 watts peak, and the weight, as Eduardo said before, is nearly half on the standard one. This module was manufactured by Acciona. This is another view. You can see the final installation, the final view, and you can see as well the microinverters, you can see only in the arrow, the microinverters installed behind the modules to convert the DC to the AC. In this case, regarding shadows and something like that, we designed to use microinverters to obtain more data and to avoid these shadow effects that I showed you before. In the picture of the right, you always can see another design of the project. This is another ventilator design. This was installed in the area close to Bilbao in Spain. This is an aluminium tray, standard one, and we use a flat design with 20 cells, okay, that give you about 70 watts peak and only weight less than 2 kilos. This one, it was manufactured by ATERSA, and it was placed in Tecnalia, one of the Tecnalia departments. I think the next slide, it's a video. Please, Franco, could you launch the video one? And I'm going to show you how fast it is to install this system. It's a time-lapse. I mean, there are speed. I can see it. Now, see, we start to install from the right to the left, and this is more or less 5 hours. They are placing the right tacks, and that's it. In 3-4 hours, the final system is completely cabling and working. Okay, let's move to the next design. This is what we call skylight, because underneath of these modules there are a skylight, and the light pass through this. The light pass through this part of the roof and go directly to an inside room. And this is the other design. This design, it was manufactured by ATERSA too, and it consists in 28 cells in serial and give you about 1 watt peak. What I told you about the Junction box, at the beginning, the Junction box, it was designed to install here because it was more easy to hide the cables, but it was worse. Then we moved the Junction box to this part of the module, and you can see the cables are, but now they are not connected. They are still in the process when this picture was taken, but at the end the cable was with this part, and you are not going to see the cables. That's the main idea of BIPV, is to integrate as much as possible the system on the building in order not to affect. This is another 2 pictures from the middle of the installation and the last part of the installation, and this is what the system will be forever. This part is not this part. The shadow reaches to this, and they are not shadowing the cells behind. That's designed to work in this way. Okay, now we are moving to the shadows elements. This is one of the design of the shadow elements. It was located in Pikermini, close to Athens, in Greece. There are 3 demos sites, one in Belgium, one in Greece, and another in Spain. In some place there are 2 different designs, another only one. These are designed to give shadow to the windows, and these are the final aspect. There are 7 cells connected in serial, and in serial with the rest of the 3 strings, and all together connected to a microinverter. This is a closer view, and this is a more closer view. You can see here the 1, 2, 3, 4, 5, 6, 7 cells, all connected in serial. This model was manufactured by Acciona, And the weight that you can see, nearly 12 kilograms, that means all BIP system. I mean, the anchored system, the framing system, and the solar cells with the infusion resin. This is the other shadow element that you saw in previous presentation. It was manufactured with Acciona, and the main goal of this design, it was the way how it's been connected. Why? Because here, as you know, the sun path go from this to other one. Okay. Then, in order to increase the performance of the system, these three strings are connected in serial with the same three strings, but in another balcony. As well, this with the another three, and so on. Then, always there are the most suitable strings connected in serial facing the sun. It was manufactured by Acciona. The weight is nearly 60 kilograms. That means all the structure, aluminum structure, frames, and so on. This is a view from beneath. You can see the balcony, the window, and this part is shadow to the balcony. Now we are moving to the roofing shingle. The roofing shingle, it's a 32 cells in serial module. It was installed in Mons in Belgium. It's about 120 watts peak and only weight 7 kilograms. It was manufactured by ATERSA, and at the beginning of the design, it was designed like that, and it was pretended just to install with only one subjection here, but at the end, in order to be sure, we add a screw here, a screw here, in order to prevent from high winds, and high winds as in last winter, and the modules are perfectly. Okay, then you can see that they reproduce like a roofing shingle, and the aspect, the appearance of the module is quite nice. Okay. Now I'm going to show you one short video, how they install this roofing shingle. This is not the speed, it's the real time. They are right now put a rubber wedge up and down, then slide to the left, okay, and then he will put another rubber wedge on the back on top, and now they will pass the cables up and down, and he connected, and that's it to next one. And now we are going to show you a video showing all the process from the installation of the racks to the installation, the roofing shingle full installation from the very beginning. There are 2 days. On the first day they will install the supporting rails. There are some work on the video that you can follow. It's video 3, please. Thank you. We place the supporting rails and omega profiles. Then put all the aluminum trays on the roof, screw to the roof. You can see the time, the down part of the screen. They right now place the horizontal is when we are going to slide all the modules. Due that it was the first manufacturing, experimental manufacturing, not nearly all with the same dimension, 1 millimeter more, 2 millimeters less. They find the perfect gap, and when they find the perfect gap to install all the horizontal track, they start to fix it to the roof. This was for the first day. Finish, go to home. And now in one morning you will see how what they are able to do. The beginning is more complicated, but when they start to practice, you can see it's quite fast. The pace of installation each module is more or less 7 minutes per module. Cabling and so on. But the lunchtime, all the modules were already installed. Well, that was my presentation. I hope all the participants enjoy it, and thank you for your time.